So the course is information retrieval. The name information retrieval formed from two words, information and retrieval. Why we need information retrieval? Because as you know, retrieval means searching for something such that we can get it easily. Especially our interest is in information retrieval. To search for whatever information users need. It may be very difficult for them. Why? Because nowadays there is an information overload, because we are in an information age where there are a lot of information, especially in such a global information system, internet. The advancement of internet makes information to grow faster. Not only information, in fact. We say there is a big data, there is an information overload. So that big data and information should be systematically and strategically managed for searching and retrieving what users are looking for, especially immediately. Whenever you need something from wherever you are, whatever it is, you have to get it immediately. Because we are living in complex, dynamic business environment, an environment that requires just-in-time response. To respond just in time, we are not expected to consume our time in information searching. We have to get that information immediately and then use it for searching. As a result, in this world, in such a globalized business environment, a lot of informations are available that are published over internet from across the world, we can say. As a result, how can we manage such a large collection of information, such a big data, a data with large volume? Large volume means not only terabytes of data, petabytes of data, zettabytes of data. What does petabytes of data mean? Thousands of terabytes of data. Even the memory space that we have is not enough for managing whatever data that I want to keep for whatever purpose that I need. So we have to have a systematic management of data and information, and then from that data information, we have to start searching and getting the relevant document, the relevant information that we need for our decision making and for our problem solving. So then what's information? Can we say information is the same as data? They are different. As we know, there is a hierarchy, starting from fact, then data, then information, then knowledge, then wisdom, then truth. Information is at the tip. Information is generated from data. Data is generated from facts. If there is no data, there is no information. If there is no information, there is no knowledge. Nowadays, we need knowledge. But to get that knowledge, we have to manage our information. So information is a contextualized, meaningful data that can be used for decision making and problem solving. Still, we can say something using information about what, when, where, who, but we can't say using information, how can I do that? The how issue requires knowledge, but still, We can convert the existing information into usable information and extract, even from data, the knowledge that we need using data mining, data analytics. So information becomes critical, which can connect us to data, which can connect us to knowledge. Information is a level of know what. If you don't know what is this, you can't know how to do this. So they are interrelated. So as a result, we have to first of all manage the information overload that we have. That's why we need information retrieval. A lot of document collections are there. Again, what does document means? Document means not only textual documents, textual data. It also includes multimedia documents like image, audio, video. Even the text that we manage may be structured, unstructured, semi-structured. So such different varieties of data should be managed, and they have to be searchable using the information retrieval system. That's why nowadays we have more than 2,000 search engines over the internet. But we are using still the well-known Google for searching. So the information explosion has to be managed. The information overload has to be managed, says that we have to relieve our users, experts, management from searching manually, which can consume their time, precious time. So given a large collection of documents, we have to design an IR system that can search through the large collection of documents whenever users are providing their queries, which is an interpretation of their information need. As a result, with such a growth of information, data, multimedia, how can we search? Books, journal articles, conference papers, newspapers, magazines, different web pages, advertisement pages, such that finally we can get an information which can directly usable for our decision making, for our problem solving, or for our research. See statistics from some of the search engines, how much data they are managing. The well-known Google manages over 3 billion web documents. Alta Vista search engine, which is nowadays also well known by different communities, covers over 215 million web pages. And it performs per day 14 million searches in more than 25 languages. The same thing, Yahoo has its own search engine. Excite has its own search engine. Ask Jim. Those two, more than 2,000 search engines who are specialized in multimedia, who specialized in a given field, who searches within a given language, again are collecting, storing, indexing, and making ready textual document, image document, video document, audio document for searching. So information retrieval becomes a must to design nowadays. We have a lot of search engines, but still those search engines may not satisfy our information need. We'll see there are a number of classifications of information retrieval by language, by data type, by specialization, in terms of performance, because information retrieval systems are language dependent, data type dependent, domain dependent. Again, they are expected to satisfy the user's requirement in behind. So what is information retrieval? So information retrieval is basically searching for relevant document from unstructured large corpus that satisfy users' information need. The process of searching for relevant document from what and what? From unstructured large corpus as per the user's information need or as per the user's query. Information retrieval is nothing but searching for something. Searching means what? Finding, identifying. But how can it find and identify document which is relevant for the user's query? I'm asking for information retrieval book. I'm asking for multimedia data retrieval book, or I'm asking for data mining book or data mining articles. How can the information retrieval system search and provide me the relevant one that can satisfy my information need? What does relevant mean for information retrieval? Relevant means among those unstructured large corpus, a document, an article, or a paper, or a book identifying for the users says that that article will satisfy the user's information need. But actually, what's relevant for the information retrieval may not be relevant for the users. Again, to what extent relevant documents are retrieved by the information retrieval system for the user's information need depends on what does relevant means. For the R system, relevant means, especially nowadays, searching at lexical level, using vocabularies in a given language. Vocabulary means nothing but distinct words. It tries to identify words from the written text and use that collection of words identified from the written text, compare them with the user's information need, again, which is specified in terms of series of words. It's trying to match words that are available within the user's query with the words that are available in a given document. So then it is just checking structural similarity between the user's query and the relevant document. Sometimes a given word structurally may be similar, but actually they may have different meaning. Take apple. What does apple mean? It has different meaning. Apple is a fruit for agricultural expert. Apple is a sport club for sport sector. Apple is a computer company for computing and informatics experts. How can we make the system differentiate? Who is searching? Is that an agricultural expert, computing expert, business expert? Or what kind of expert is searching, and how can that expert be satisfied? The communication is in terms of text. So it has to move basically from structural searching to semantic based searching. It has to understand the meaning of the user's query it has to understand the meaning of every document that it searches. Then finally, it has to match meaning-wise to what extent the user's information need is satisfied by retrieving a given document. So basically, relevant document means either the document is structurally similar with the user's information need or user's query, or else semantically the document retrieved is similar with the query users are providing for the system. Already structurally designing the system is done by different experts, but still we have to go for semantically designing the system. Says that the system has to understand the meaning. So searching should be meaning-based, semantic-based. But when we are talking about information retrieval, even if our concern is on text-based information retrieval, nowadays information retrieval has many applications. Like our documents are not only text-based, they may be image-based. Even the texts are nowadays digitized and available in the form of image. There are a number of text documents which are available in the form of text document image. So how can we search with a document image? How can we search with an audio? How can we search with a video? Because the documents that I need may be available in image form, in video form, in audio form, in text form. I can't design one system that can manage all the different types of data because internally the content is different. How can you define text? Text is nothing but a series of words that are organized, a series of characters that are organized to form words, and a series of words that are organized to form phrases, a series of phrases that are organized to form sentences. In such a way, we can go defining. So at the back of any text document, there are characters that we use. And those characters have their own ASCII or Unicode that can make the computing system directly understand them. But what about image, video, and audio? Image is a series of pixels that are organized in a given two-dimensional space. And the pixels have no ASCII or Unicode. They can't be directly accessed. They are indirectly accessed. As a result, the system that we design for text can't work for image. Even go to audio also. Audio is internally a series of waves or signals that are flowing in time. We have nowadays two groups of data, time dependent, time independent. Text and the images are time independent, audio and the videos are time dependent, because in audio and the video, whatever you see is adjusted in time. As the time goes, the audio and the video is also flowing as per the adjusted time, so then you can start understanding them. But in image and text, there is no time adjustment. The content should be available at the same time. I have to read the text and understand, or I have to see the image as a whole to understand it. Videos are a series of images or frames or objects that are organized in time. So as one image is appearing in our screen, others are waiting at the back. When that image is leaving the screen, another next screen is coming to our screen. As a result, how can I search? So nowadays, information retrieval has many research areas, even language-wise. How many languages are there in this world? Almost more than 6,000 languages are there in this world. What about in our country? Again, more than 18 languages are there. Even we have our own script, Ethiopic script, which can be used by Semitic language. In the world also, there are many writing systems, even if Latin is dominating. Still, we have many writing systems that are used for producing textual document itself. So another system which is designed for one language may not be usable for another language, even if they are written with the same, say, Latin script. Afan Oromo is using Latin script. English speakers are also using Latin script. But another system designed for English language can't be used for Afan Oromo. Why? Again, the language difference is there. Lexically, syntactically, semantically. So even when we are designing another system, we have to take into account for which data type we are designing. Because in general terms, our data types are classified into 4. Text, image, video, audio documents are there. Image includes also graphics. Videos are including also animations. Audios are including speech and music. Texts are including structured, unstructured, and semi-structured. Especially the unstructured one is challenging because in an unstructured text, it's a free text. There are texts written in a given document. The system has to understand every document by scanning through the whole content in that document. Structured one is more simpler because everything is tabulated, and we know column-wise the attributes, row-wise instances as per the attributes given. So we can directly even search within structured text. But how can we go for basically our system concerned about unstructured documents? That unstructured document may be text, document, image, document, video, document, or audio document. Nowadays, there are many attempts to design a text-based information retrieval system, content-based image retrieval system, content-based video retrieval system, audio-based, content-based audio retrieval systems. But still, the users may need not only image, but also text. Not only text, but also video. Nowadays, whatever users are searching, if they are using Google, they have to specify their query in text form. So whatever we are searching is text-based. How can I search using text query for image? How can I search text using text query videos? The internal content is totally different. In fact, the best way is using text, searching for everything, using image, again searching for whatever we need. For that, nowadays there are attempts around multimodal information retrieval or bimodal information retrieval, not only unimodal information retrieval. Just rather than designing only for one of the data type, we have to go for designing for multiple data types, like multimedia information retrieval, for instance. Again, language-wise, our system is challenged because our systems are not only data type dependent, but also language dependent. Because every language have its own syntactic grammar rule, semantic meaning, lexical vocabulary or word formation. As a result, whatever systems that you design for one may not work for the other. But the problem is, there are a lot of languages in this world. Again, we have also more than 18 languages in our country. How can we design an R system for 18 languages with their own grammar, with their own syntactic and semantic formation? As a result, nowadays the attempt is towards cross-language information retrieval, bilingual information retrieval, or multilingual information retrieval, rather than a unilingual information retrieval. Rather than designing an information retrieval system for one language, we have to go for designing an R system for multiple language. We can apply cross-language information retrieval that can accept user's query in one language and the searches in another, documents that are written in another language. If I'm using cross-language information retrieval, if my query is in Amharic, it can bring documents that are written in English, for instance, or in Chinese, depending on what kind of cross-language information retrieval system we design. The most generic one is multilingual. You can design a multilingual R system that can take into account different languages, that can take into account different documents that are written in different languages. And whenever you give your queries in one of the language, it can retrieve all the documents that are written in multilingual. So still, such systems are expected. The other thing is nowadays also there is an interest to design an R system which is specialized in a given field. Designing a search engine that can work in medical field, that can work in agricultural field, that can work in computing field. So nowadays, rather than general purpose, we need a specialized search engines or information retrieval systems, a system that works in a given field only. Google is a general purpose information retrieval system or search engine. Yahoo search engine is again a generalized purpose. There are medical search engines which are specialized. If you go for generalized purpose, the search engine may serve the whole community from wherever they come. But the problem is getting relevant document is very difficult for my just-in-time response for a given business opportunity, for instance. So sometimes specialized search engines are critical, says that they can search only in a given field, documents that are written in a given field. Then they can come up with some of the documents which are more relevant from that given field for that given query. Still, search engines are also challenged by performance. So still, the need to improve both efficiency and effectiveness of an R system is expected. To satisfy users' information need, many attempts are there. Still, Google is working to optimize the search engine because the recallability of the system is still minimal, even not reached to 15% recallability. Recall means remembering some of the relevant document out of the total number of relevant documents available in the document corpus, in the document collection. So the recallability of the Google search engine is still less than 15%. How can we optimize it such that its recallability can be around 18%, 19%? At the same time, we are also expecting precision. Whatever it retrieves should be as precise as possible, relevant for the user's information need. But the problem is, recall and the precision are inversely related. If you increase recall, the precision of the system will decrease. If you enhance the precision of the system, the recallability of the system will decrease. So how can you compromise between recall and the precision? Nowadays, many attempts are there to make the system not only understand the structure, the lexical structure, the syntactic structure, the way we are writing our query, and the way the document is written. Many attempts are there to make the R system semantically understand. So it's better to go for designing a meaning-based IR system that can understand the conceptual meaning of the query formed by the users, the conceptual meaning of the document, then sees the similarity of the conceptual meaning of the query with the document. But again, maybe what I need now may not be required next time. Obviously, information need of users is changing frequently. As you satisfy one of your information need, maybe your next need is triggering you to retrieve another type of document which can satisfy your information need. At least we are expecting the information retrieval system to satisfy the current information need of the user. Sometimes we have to go for question and answering systems. Question and answering systems are exactly providing an answer for a given query. If I ask where is Ethiopia, it has to tell me exactly where Ethiopia exists within Africa. Or if I ask who is the president of this country, it has to tell me exactly this is the person who is the president of this country, rather than giving me the document where whatever users are searching as in the form of queries. So IR systems, IR researches are nowadays becoming interesting because of the different challenges coming from the data side, language side, field side, performance-wise. Why more attempts are there, more researchers are there, or more search engines are there for searching and retrieving relevant documents for the user's information need? Because information retrieval system is acting as a bridge between the reader's world and the author's world. The reader's world is a world where users want a document to read or visualize or hear, depending on the type of the data, type of the document. The author's worlds are the world where those documents are prepared or written or produced, again, depending on the data type. So there are two worlds when we come to information retrieval. There are reader's world and there are author's world. How can we bridge the gap that exists between the two worlds? If we allow them, the author's world to present for the reader's world and the reader's world to access the author's world, since they exist in a distributed manner in such a globalized world. It's very difficult to make them meet directly, since the documents themselves are available in this world, since the information need is available also in this world. But distance is one constraint, time is another constraint, language is further constraint. As a result, we have to have an information retrieval system that can simplify the way the authors are bringing whatever documents that they have: textual document, image document, video document, audio document. The same is for the readers or users world. Their system has to accept the user's requirement, information need, and then search from the author's world, and then simplify the way the users or the reader's world gets whatever information or data that they need in the form of text, audio, video, and image. So our major concern is the black box that can bring into one village the user's world and the author's world, such that authors can easily present their document and the users can easily search within that document. So the issue is, how can we design the black box? The black box is the information retrieval system or search engine. That means we have to index the large collection of documents that comes from the author's world. We have to accept the user's information need and then search for the relevant document as per the user's information need. So information retrieval systems need two systems further. So information retrieval system has further two subsystems: indexing and searching. Indexing service the author's world, searching service the user's world. So the indexing is responsible for organizing the large collection of documents. Searching is responsible for finding something relevant from the document collection as per the information need of users. So how can you design this system is a major issue. So when you are designing any system, the first thing to think is, as a system, the language of communication within the system. System means different components that are organized together to achieve a common goal. Information retrieval system as a system is responsible for searching and identifying relevant document for the user's query from the large collection of documents organized in its index. So what kind of language they have to speak? As per the language that the different components within the information retrieval system uses as a medium of communication, the system has to be designed. Information retrieval system is a complex system because we have to start thinking what kind of unit of communication it has to use. Because when documents are written, take textual document, internally there are characters, there are subwords, there are words, there are a collection of words in the form of phrase, there are sentences, there are paragraphs, there are pages. What should be the unit of search? What should be the unit of organizing the document? So then what is the unit of the different components communicate within the information retrieval system. Nowadays, words are used. Words are used as a medium of communication internally within the information retrieval system. So the issue is, what kind of word do we have to use? Because when we are writing words, sometimes we are adding an extra character into the word to take into account time, to take into account subject, to take into account place or situations. I'm writing a given word like develop. By adding developing, developed, develops, we are adding as a suffix. We are adding some extra characters as a prefix. We are adding in between the words, somewhere in between the different characters within the word, infix. Or we are adding both at the beginning and at the end of the word, circumfix. As a result of which we are not expected to confuse the information retrieval system to consider them as different words. Even sometimes you are using capital letters. Sometimes you are using small letter. Sometimes you are mixing them. So the terms should be carefully, systematically selected for using them as a medium of communication. Even words may be polysemous, synonymous. A given word may have multiple meaning, as we said apple. Different words may have the same meaning. Take Ethiopia, Abyssinia, 30 months of sunshine. As a result, how can we compile our terms that can be used as a communication within the system, such that the information retrieval system effectively, efficiently serve our users to get whatever documents they need from the author's wallet. Even sometimes we have to also know the most important term as compared to other terms, because all terms are not equally important in representing a given document. We are giving sometimes when we are writing a document for some of the words as compared to other words. Even there are words that are frequently appearing but have no meaning, like stop words. I'm using again and again a. I'm using again and again end. End has no discriminatory power for separating one document from another document. End is equally used in any document in the same way, because end is a connector. A is an article. As a result, how can we identify terms that can enhance the effectiveness of the information retrieval system and also represent the document which we are searching for? Unless and otherwise, the document is exactly, precisely represented using the document, using the words that are describing it, we may not identify that document. So term selection is one of the issues, or word selection is one of the issues. Starting from identifying the word from the free text. Here in the slide, an information retrieval system serves as a bridge. It says, how can I identify every word? AN is one word. Information is another word. Retrieval is a third word. How can I separate N from information? Sometimes multiple words are one word. Sometimes different words are separated by space. Other times by comma or bracket or dot. As a result, we have to have a mechanism of identifying exactly, precisely the words, the terms that can be used for representing a given document, that can be used for representing a given query from the users. Then again, when we come to relevance, how can I say this document is more relevant than this document? Because all the documents are not equally relevant for the user's information need. How can I prioritize? Nowadays, there are different similarity measurements used, but what kind of similarity measurement to use depends on the information retrieval models that we use. Many information retrieval models are there. Vector space model, Boolean model, probabilistic model, linguistics-based model, knowledge-based model. Which one we have to use? Again, it depends on the language that you are using, then the type of systems that you are designing. Are you designing a generalized purpose or a specialized search engine? Are you designing an information retrieval for limited document collection or unlimited document collection, limited data type or for unlimited data type? So depending on the objective of the system, accordingly, we have to select the similarity measurement. Because there are many similarity, dissimilarity measurements that are trying to see to what extent a given document is similar with or related with a given user's query. We can say the document is relevant for a given information need if it is registering highest similarity with the information need user's query. So as a result, our major aim in this course is looking at how can we design the black box that can bridge the gap between the reader's world and the author's world. Once we design the R system has to have a mechanism of indexing the document corpus. So whatever R systems that you design, it has to have an indexing module. A module or a subsystem responsible for organizing the document corpus that comes from the author's or producer's world. And the IR system should be communicated or linked to the users, the reader's world, the user's world, the users who want us to consult the document that are produced or authored by the author's world or the producer's world. So as a result, the IR system is bridging the gap between the author's world on the one hand, the reader's world on the other hand, or the user's world on the other hand. As a result, it has to systematically organize the document corpus that comes from the author's world. It has to treat as per the user's query in helping them get the document that they need for their immediate problem solving, decision making, or research. For that, we need to design a searching subsystem. The searching subsystem is responsible for searching from the document corpus which is indexed, the one which are more relevant for the user's query. And finally, we are expecting the R system, after accepting as an input user's query and the document corpus that comes from the author's world and the reader's world, it has to generate as an output ranked relevant document. The first thing is the document retrieved by the R system should be relevant. What does relevant means? Relevant means a document which is similar with, or a document which comes from the author's world which is similar with the user's query. To what extent? The document is structurally, semantically similar with the user's query, such that that relevant document satisfies the user's information need. Again, even if the document is relevant, all relevant documents are not equally relevant for the users. Or else, all relevant documents are not equally similar with the given user's query. As a result, we have to rank them based on the extent to which they are relevant or they are similar with the user's query. So the R system is expected to generate ranked relevant documents as per their relevance, as per their similarity with the user's query. So whatever the list that you are observing when you are searching using query, they are retrieved in ranked order. Always for the search engine, the first document is more relevant than some document as the middle. As the document is far from the first listed document, that document is relevant but not relevant as those which are given priority to appear in the first listed documents. So the relevance of the document decreases as it is listed at the bottom of the relevant documents. So ranking is very critical when the R system is retrieving documents as relevant for the user's query. So those documents which are more relevant should appear at the front of whatever it is retrieving, or at the first some K lists among those retrieved. Is our system the same as search engine, or web search systems, or web search engines, or web information retrieval systems? Mostly they are similar, because like an R system, it has to communicate with the author's world, and it has to communicate with users or readers world, and it has to generate relevant documents in ranked list. It has to give more priority for the most relevant document, and that document should appear in the first K lists as per the similarity measurement, as the similarity score. What makes web search engines different from information retrieval systems is web search engines have unintelligent spiders, crawlers, or they are also called bots. Those spiders or crawlers are responsible for always checking the web. Web is basically forming a graph because they are linked with each other. As a result, the spiders or crawlers are responsible for checking the web. Then if there is a new page published over the web, they can bring it, its address, its title, and then index it within the indexing list. Or if there is a web page which is already dead, they remove it from the index. Or if there is a modification of the web page, they have to also modify the indexed list of web pages. So as a result, within our web page, there are three things that are happening. Frequently, updation is there within the web. Either new web pages are added, or new websites are added, or the web page itself is refreshed, or the content is modified, or else maybe the page is dead, no more useful, or no more available. As a result, such changes within the web are controlled by the spiders or crawlers, which are intelligent. And they are frequently also updating the index file. So the indexing is frequently updated. So as a result, there is also an issue in selecting the indexing algorithm, the indexing file. There are many indexing algorithms available, like inverted file, signature file, sequential file. Which one is more effective? We have our own criteria. We'll see when we reach to that indexing section. Using those criteria as per the purpose of the R system, we need to select the most effective, efficient indexing algorithm. Beyond that, whether it is a web search engine or an R system, they are designed to bridge the gap between the author's world and the reader's world. And according to the user's query, from the author's world, from the organized author's world document, the R system is responsible to identify, search, and retrieve those relevant documents which are satisfying the information need of the users, syntactically, semantically, depending on how the R system is designed. Nowadays, mostly syntactic similarity is considered. That means structural similarity is considered. Based on the words a document contains against based on the words available in a given user's query. So when we are designing the R system, what are within the black box? Basically, as we said, any R system has an indexing subsystem and searching subsystem. Why we need the indexing subsystem? To manage the document corpus that comes from the author's world. Why we need the searching subsystem? To handle the information need of the users. So to handle the author's world and the user's world, we need indexing for the author's world, searching for the user's world. Basically, the indexing can be done offline, but the searching should be always online. When we are indexing, there is no need of users' involvement, but the searching is happening when the users starts interacting with the information retrieval system or with the search engine. Even the name search engine is given because the search engine is available to serve the users in searching and getting the relevant documents that they need. So the indexing is done at the back of the search engines, and at the front you will get the searching facility for the users. So searching is an online, but indexing is an offline process. To some extent, especially when we are defining the language of communication within the retrieval system, and in identifying as per the language selected, the important terms for organizing the document, for identifying the user's query. The two search engines and the searching subsystem and the indexing subsystems are using the same text operations when they are dealing with the text document collection. The text operation is responsible for identifying, as per the selected unit of communication within the retrieval system, the unit which should be used for indexing the document corpus, the unit which is used for searching as per the user's information need. As we said, nowadays, Information retrieval systems are designed by taking into account words. Words are used for indexing. Words are used for searching. So the unit of communication within the information retrieval system is nothing but words. And they are called terms. Sometimes they are also called vocabularies. Sometimes they are called content-bearing terms. But anyway, we can say we need terms. Terms may be simulating the word, or terms may be exactly the word. It depends on what are the steps that we considered in selecting the terms, in identifying the words, for describing the document, for representing the user's query. So text operation is responsible as per the selected unit of communication with the retrieval system to identify the unit. Nowadays, since the words are used internally for organizing the document and for defining the user's query, text operations are responsible for identifying the word which can describe the document, the word which is describing the user's query. So within the text operation itself, there are a series of steps like tokenization, stopword detection, normalization, stemming, and sometimes the use of thesaurus for grouping together different words with similar meaning. So the text operation is trying to come up with the logical view of the textual document that comes from the author's world, and the logical view of the user's query. Once we apply the text operation on the document corpus that comes from the author's world, we have to index it. For indexing, we have to select the indexing structure, the indexing file, that means, as per the indexing algorithm selected. Then the document corpus should be organized in an index file. We have to make them ready for searching. If there is no indexing, there is no searching. If there is no searching, there is no indexing. So they are interrelated. Even if the retrieval system has two subsystems, those subsystems are interrelated to enhance the effectiveness and the efficiency of the information retrieval system. We need also the text operation for defining the user's query. The users are providing through the user interface their information need. Their information need should be converted into query to make it ready for searching. To convert the information need of the users into queries, we have to apply the text operations. That means tokenization, stopword detection, normalization, stemming, whatever steps that we take for preparing the document when we are trying to index it. The same step should be applied also when we are preparing the queries for searching. Once the query is formulated, then searching is possible. But the searching takes as an input the index file, because the index file is organizing the document corpus, and it has to accept the queries, and then searches the queries within the index file to identify the document which contains the queries. Says that finally it is identifying relevant document from the index file that are satisfying the user's information need. But after searching and identifying relevant document, they are not just listed. The relevant documents are listed in ranked order. The first document is more relevant than other documents, other relevant document. The second relevant document is more relevant than the remaining relevant document. So the users are provided back relevant documents in ranked order. If they are not satisfied, they have to modify their queries. In fact, we'll see. There are also the retrieval process nowadays is also containing some query operations that tries to optimize the user's query as per the relevant documents that are available in the index file. So our course basically deals with information retrieval course basically deals with one, the text operations to identify the terms that should represent the document collection that should represent the query given from the users. Then, as per the terms selected from the document collection, they have to be used for organizing the document collection in the using the selected indexing structure. Many indexing algorithms, indexing structures are available. We have to select as per our requirement, but nowadays the most widely used one is the inverted file. Then the searching part. When the searching is applied, it needs a model.